By girdling all the trees here, we're able to compare what's going to happen in this forest after these trees die to what's going on in our control forest. Any differences we see are due to what we've done to this forest by girdling all these aspen and birch trees. And what we expect then is these will die out and we'll get the growth of all these understory trees like the pine, beech, maple, so forth will come up, and then we expect to see an increase in the amount of carbon dioxide or carbon that this forest takes up every year. These aspen-dominated forests here, it's about 100,000 square kilometers. I don't know how much that is in miles, but a big area in Michigan, Wisconsin, Minnesota is in very similar condition, where you have an old aspen forest, and what you see around us here is the white pine coming back up. You see oak and maple, and this will be the new forest in 50 years. And so it'll be a very different kind of a forest, and we suggest that these forests, the new forest, the forest that's growing up underneath this aspen, may actually have an increased capacity to store carbon compared to the aspen that's growing here now. So rather than having having this declining carbon storage capacity, we suggest it actually might be increasing, and that's what this experiment is all about, to accelerate this natural process of succession and allow the pine and the hemlock and the oak to actually come up and take their position in the canopy a little faster than they would, so that we can actually address that question of what will these future forests be like.
Biological Station is a perfect place for doing this sort of research because it fits our mission. We have the long-term records against which the responses of this experiment can be compared. And we have a diverse set of researchers interested in all kinds of questions. What drives our research is trying to understand how forests take carbon out of the atmosphere, how they reduce CO2 to organic matter stored in tree wood, stored in soil organic matter. The question is, as the climate warms and the tree species change naturally, whether that carbon removal rate will increase or decrease or stay the same. We don't know. We won't know until we make the measurements, however. So that's what's interesting about science. You basically generate an informed hypothesis, but we need to make the measurements and do the treatments to make a reliable prediction.